Hello everyone and welcome to another Train the Trainers video. Today we will be demonstrating how to drill a monitoring well. These are used to keep track of or monitor the quality or quantity of groundwater at a specific location. We are drilling 4 wells on the University of Alabama campus in order to monitor parameters of the groundwater, such as the water quality and quantity here. The well that you can see being drilled in this video is located on the front lawn of the University of Alabama Law School. And the people constructing the well in this video are geologists at the Geological Survey of Alabama. As you can see, the soil kind of is gray in this part of the video, and as we go further, it will change to more tan, sandy soil. This is because as this auger goes deeper into the soil and into the ground, there are different layers of soil in the ground that we'll be able to see. And all these changes are recorded and put into boring logs, which are documents that state the type of soils at the different depths at the location. First, you need to drill using an auger to drill down to the height that you want the well to be. In our case, we will be constructing short wells ranging from 15 to 30 feet. Our shortest one is actually 14 feet because we will hit the bedrock if we go any lower. The wells that we are constructing will also be about 2 inches in diameter, which means that we will be making a 6-inch diameter hole with the auger to allow for the proper placement of these well materials. The general rule is about 2 inches on either side, or adding 4 inches to the diameter of the chosen well. That diameter and the heights of the well will determine which type of auger or drill that you need to use. Here we have an overall diagram of our monitoring wells. As you can see here, it starts with a well point at the bottom, 2-inch PVC slotted screen connected to 2-inch PVC casing that will run up to the top of the well. We have a gravel pack and backfilled sediment to keep everything in place and filter the groundwater a little bit. We have the 6-inch bentonite seal to seal off and not have as much intrusion. And then we have the 6-inch bentonite and cement seal, along with the top of the well casing that will be flush mounted to the ground. Now we will actually be getting to placing the materials in the well, and first the piping must be placed. Now we are using Schedule 40 PVC pipe with a 2-inch inner diameter, and on the end of this pipe there will be a well point that is cone-shaped, which allows for the piping to firmly plant into the ground and to not move too much while the fill material is being placed. The bottom portion of the pipe is actually screened PVC, while the rest of the piping will be normal PVC. So the bottom portion of the pipe will have little slots in it. This pipe is then placed into the borehole that we just created vertically. And now that it's placed, you'd think that we're almost done, but we're actually not. If the PVC were to be left like this, it would move around and we would not be able to have it as a functioning monitoring well. So that means we need to anchor it into the earth with cement, bentonite and silica sand, and gravel. Now that the PVC piping has been placed, the outer materials must be placed in the borehole as well. First, we're going to be placing a gravel pack in to the same height as the slotted screen PVC. Then a 6-inch bentonite seal will be placed in the well as well. Then we have backfilled sediment to further keep it into place, as mentioned in the schematic portion. And then a 6-inch bentonite and cement seal will be placed on top of this sediment. Now all the seals in the well are placed to provide a barrier to the migration of the groundwater between when it's surface water to when it's groundwater. And this is so that the water does not get cross-contaminated, and it gives it time to slowly matriculate down. After all the materials have been placed and the PVC is cut to fit the well depth, a small concrete pad will have to be poured. This will further help keep the pipe in place and aid others to identify where the well is for future use. The steel cap or casing will then be placed on top of the concrete once it is cured. Flush-mounted caps, or caps that do not protrude up from the ground, were used in this case, but they do not have to be flat on the ground. They can also protrude up. Now, groundwater is still a very unknown variable in many instances, especially on the University of Alabama campus. Therefore, by creating a groundwater monitoring network that this well is being drilled is a part of, we will be able to identify the flow path, quantity, and quality of the groundwater. To do this, data sondes, which are Aquatrol 500 multi-parameter data sondes manufactured by In Situ, will later be placed in these wells to monitor many different parameters, such as water level and pH, to help determine the groundwater flow and quality on this campus. These will then be connected to data loggers that are also manufactured by In Situ called view links in order to record all the data. Thank you so much for watching our monitoring well construction video, and we'll see you next time for Train the Trainers.